Um, hi, hi guys. So I'm trying to do the visualization for the project. It's quite snappy, so I'll just delve straight into it. So this can be a guide for all of us. Okay, so I'll be using Power BI. Uh, there's a message you received from the president, and then our new visualization expert. Her name is it Delilah said. So let's just go on. Hello, team. I'm excited to work with each of you on this pivotal project to highlight the findings from the survey data you worked on and to add a dimension to our analysis, looking at the gender inequality in the water access in Maji Ndogo. You may wonder why we are doing this. The answer lies in the power of data to illuminate truth that are often overlooked. Our goal is to make these truths not just visible, but visceral, compelling people to act. I'll explain some of the data we have in a minute, but we have a lot of thinking to do before we start creating. Let me just get this and move on to the next one. Right. So here's the link to the latest version of the data. So MD summary CSV. If you are using a virtual machine for Mac users, I have some advice, blah, blah, blah. I hope majority of us are using Windows. So let's just move on. The data is now in one table to keep it simple. Since the new data is going to guide us, we have to first analyze it a bit so we know what story the data has to tell. First things first, go ahead and import the CSV file into Power BI. Just one thing to look out for. Power BI tries its best to identify the data types of data, but it fails sometimes. It may identify these columns as text, so percentage male, percentage female, and percentage child, but they are actual numbers. They are actual numbers. Make sure you check that the data has the correct format in the table view. So what this is trying to say is that when we look at the MD summary in the table view here, oh, is it MD summary? So percentage male, percentage female, percentage child. Am I opening this one? Right. So MD summary. So we have percentage male, percentage female, percentage child. Before then, the data in here were all text. Okay. They were all text like this. Okay. But since they are percentages, I can't change it to the data type. I can't change it to a percentage because when I change it that way, look at what happens to the data. So let me format the text. I'm sorry. Well, I think earlier on I saw I saw a percentage in here, but it's not. So I just made it a decimal number. I didn't make it a whole number. So I made it a decimal number, right? And then since they are already in decimals, it makes sense because if I should change this to percentage, let me see. Good. If I should change it to percentage here, you realize that we have it in, what's the name? The content change, the text changes, everything changes. Instead of 2 decimal places, now we have six numbers here in 2 decimal places, which will throw everything off gear, right? So let's just maintain it as general as it is, but then keep it all as decimal numbers. Okay. So those are the changes that I made. And also I realized that for number of people served and hour of day, they were all text. So I had to change this one to whole numbers and then hour of day also to whole numbers. And then time in queue as well, I had to change it to whole numbers. The reason I did all of these is because if we are supposed to do an average aggregation, let me say an aggregation on any of those things, if it is not specified as a whole number or maybe a decimal or anything, we will not be able to do those aggregations. So I needed to make it that before I begin, right? So once this is done, once this is done, these are what we are supposed to work on. Okay. So the hour of day at the time of record, and then this will help us aggregate by the hour of day. So that was the reason why I changed the hour of day to the whole number. Day of week is the day of the week from the time of record. So this will help us also aggregate by day of week. Remember, day of week are just normal days, Monday to Sunday, so we don't need to do any aggregation on that. But it will help us when we're aggregating by the day of the week. Percentage male, female, and percentage child, as they say, percentage of men in a queue at the time of record. And that's the same for female and child. Now that the data is in, let's recap the main points from our SQL analysis and visually represent these. Okay, so if you can remember, we got these analysis from our last project we did in SQL, okay, where we had most water sources and rural, 43% are using share tabs and so on and so forth. So we already have an idea of these analysis. So let's start with our national level results. Okay, so we are going to make a couple of visuals on the same page that communicate the results of the survey at a higher level. At a high level, these are the insights we want to show on the page. So we want to show rural versus urban. 43% of the people are using shared tabs. 31% of the population has water infrastructure in their home. And then I think this is water infrastructure problems, so to speak. And then 18% of our people are using wells. Okay. So to do this, we create the following visuals on a single page. So first, we'll create a pie chart to illustrate the total urban and rural population split in Maji Ndogo. So we use sum of number of people served, and then we'll split by location type. Okay. So first off, we're using the MD summary. Let me toggle that one down. And then a pie chart. So I'll select pie charts on the canvas, onto the canvas. Let me open it up. And then we'll use sum of number of people served and split by location. Okay. So what is number of people served? This is number of people served. Let me drop that one to values. And then we are going to split by location type. So this is location type. Let me put it in legend, at least it makes it easier. Yeah. So from here, we can see that about 69% of the people having access to water are in the rural areas, right? 69%. Okay. Now, the second thing is to create a column chart showing the total population using the various water sources. So a column chart, I think this will do more. Let me use the cluster. Oh no. So yes, there is another issue. I always need to click outside of the chart in order to select a new one. If not, whatever we do on an already selected chart will change, right? So column charts. And then the sum of number of people served and was split by type of water source. So on our y-axis, let's put the number of people served there. That will be sum. And then type of the water source value. Let me put that on the x-axis. Right. So this is how the data now looks like. Okay. So we have shared tab representing 50-something million. Well, 40 here million. So 4 million something. So this is how it's going to look like. We didn't touch on this, but I just want to, I think it doesn't matter. Let me just leave it in order not to confuse people. All right. So this is the first thing we are supposed to do. So there's a hint here. It says we should remember the population was estimated to be 28 million. If you get more than that, remember that visit count is equal to 1. Okay. If you get more than that, remember that visit count equal to one prevented duplicate record. So you use it as a filter condition by adding visit count to the filter pane and selecting one. Right. So clearly we can see that share tab has about 54 million, but we've been told that the population was approximately 28 million. So technically there are duplicates in here. So we need to filter the visit counts, right? So let's put it here. And then we'll set to 1. So I can use basic filtering here. I'll just select 1. And then this is how it looks like. Okay. So now we have share tab for about approximately 12 million. And then the rest follows. Okay. So we should have something like this similar here. So let's proceed. I have this once. The only words design. Oh, I think we don't. It doesn't really matter. It's talking about the colors. Maybe we would like to do some small coloring. Maybe change the color. This will also do. It's not too dark on the eye. So the only words design than a pie charts is there's several of them. Pie charts are hard to read for humans, but when there are a few categories and the differences between them are clear, pie charts really help us tell the parts of a whole story well. For example, you can see that a lot more people live in rural areas compared to the urban ones very easily. Okay. Because we have a couple of water sources, the bar chart makes it simpler to understand the breakdown of the source data. The most obvious part of the bar chart is just how much more people use share tabs compared to others. 43% doesn't seem that big, but since the next largest source is only 18%, it is clear that share tabs makes up a large portion of Maji Ndogo's water supply. However, the bar chart makes it a bit harder to understand the relative proportion of share tabs to the total population of 41%. Okay, so the bar chart makes it a bit harder to understand the relative proportion of share tabs. So now let's duplicate the page we made by right-clicking on the page and creating a duplicate. Okay, and then switch the data sources so that the pie chart shows the water source type data and the bar chart the population breakdown. So let's do that one. Let me duplicate this. Okay, and then let's interchange. So I'm going to change this to a bar chart, and I'll change this to a pie chart, right? So duplicate a page, right? Once you have made them, compare them to the first page. How do these compare to the first set we made? It is very easy. We can compare the rural to the urban here as well, because we can tell that about 48 million are served. Access water, the rural people, 48%, 48 million of the people in the rural areas access the type of water source compared to 21 million. And then looking at the pie chart here, unless of course we put our cursor on, this is for share tab, we get the share of the pie on the type of water source that these population is serving the population. Okay, even though maybe it might be a bit easier to read the data from here, well, I think in this case it's not really clustered, so it's very easy for us to understand. We have only 5 water sources in here, so it's very easy for us to understand this. Which visuals are easier to interpret? I think depending on the level of experience, we can easily interpret, but on the layman's, level, maybe it might be a bit difficult, right? Do you learn anything more by switching these values? As I said earlier, assuming the type of water sources were quite a lot, maybe about 10, it will be a bit clumsy, clustered, and it will be very difficult to interpret the data on here. And what story do these visuals tell compared to the other sets? Well, as I said, it depends on the level of, understanding or experience you have with this. So based on that, I think I will stick to the first one, because with that one, you can even see maybe a trend, right? Comparing this bar chart to the pie chart here. Though this is a bigger one, but the column chart in here, makes it very, very easy to see the trend and the slope. Okay, so let me delete this and let's stick to the first one. Once you're done, delete the duplicate page and rename the original page. So I already have national here, so I'll make this national copy. National copy. So I'm just double clicking in here, or I can right click and rename. Okay. Since we made these two visuals on the national page, Power BI connects the underlying relationship in the data in the two visuals. We can select urban on the pie chart, and only the urban data is shown on the bar charts. So when we select urban, this is the information for the urban centers. So when we click on Share Tab, we know that about 3 million people have access to Share Tab in the urban centers. And when we come to river, it's highly negligible, 687 as compared to 2.3 million. Okay, so we see the impacts in here. And when we click on only rural 2, it gives the inverse. So this one is about 1.67 for river as against 2.36. Okay, right. So the national bars are now a bit lighter, while the urban data is now highlighted on the bars. Clicking on the Share Tab bar will filter the data for the pie charts, showing how many people share tabs in the urban and rural areas. So when we click on Share Tab here, now we realize the implication it has on the pie charts. Okay, so when we take the data for the rural centers, it is 48 million. 48 million people in the rural centers have access to all the type of water sources, okay, put together. But once we filtered Share Tab out, we can see about only maybe 8.9 million, representing 12.75 of the people in the rural centers having access to Share Tab. Okay, and when we go to urban 2, we have about the entire population is 21 million. That is about 30% of the entire data. And then when we highlighted the Share Tab out, we realized that just about 2 million of the entire population in the urban centers have access to Share Tab. Okay, and that is about 4.26. If we should compare this to Tap in Home, we can see the real difference. Okay, because here now, majority of the people also have access to Tap in Home in the urban centers as compared to the rural centers. So that is how interactive this can be, right? So can you also see how the rural highlight in the pie chart is a bit larger than the urban? So just a note, if you'd like to see the national data again without any process, click on the highlighted bar, right? It is important to remember that I had to explain the interpretation of the pie chart, highlighting to you. It is always better to create visuals that don't need explanation and require little effort to understand. So now select Tap in Home bar. What do you see and how can you interpret this? So Tap in Home bar, what we can see, I think I touched on this. What we can see is that from the rural area, we have about maybe 2 million having access to Tap in Home. That is 2.97 or almost 3% of the entire 69% of people having access to water source, right? And then when we take the urban center too, we have about 2 million having access to Tap in Home, and then as against the actual population of 30 million. Let me take this call. Okay, so I think moving on. So with one page and using only 2 visuals, we could illustrate insights 1, 2, and 3 and learning something about tabs installed in urban versus rural houses we didn't know before. And this is why I love visualizing data, right? So as we have it here. Okay, so let's move on. Next up, let's take on the second part of Insight 4, where is the infrastructure looking? On the visuals with the most impact, one of the visuals with most impact is the map. So this is one of the crucial visualizations we use a lot. Since Maji Ndogo isn't well known, we have to use a custom map to visualize the data. Here's the link to download. So we'll download these two. And then we'll add a page by clicking on the plus of the report view and create a new shape map visual for visualization. So on the plus, we're going to create a shape map. Because I've already worked on the project, I have already treated this, but I'll take it again. So let me go here. Let me go to file options. I'm just trying to do something and I'll relaunch, Power BI again. Right. So yeah, let me uncheck this and okay. Right. So this is what I'll do. I'll open the Power BI again. Okay. Let me add a new share. Okay. So I'm adding a new Power BI. Let me open the one that I already have. Oh. Did I even save it? Yeah. A minute, please. Let me just work with this. Okay. So so we can see that over here we do not have the shape map. Okay. We are told that we have to create a new shape map visual from the visualization tab. We only have the map and the field map. We don't have the shape map. Okay. I don't know if we can use the field map, but we've been directed to use the shape map. In order to bring the shape map in here, right, we'll go to file and then options and settings. Then we click on options again. Once this pop-up comes, we'll select preview features and then we'll toggle shape map visual. We'll toggle it on and then we'll click OK. Once we do this, we'll be told to restart our Power BI, which is normal. Okay, for that to take place. So what I'll do now is let me close this and then this as well. And then I'll open Power BI again. Okay. Okay. So I have the Power BI open now. And we can see that we now have the shape map here. Okay, right. So now let's move on to the slide and then continue. So we are told to create a new shape map from the visualization. We'll add a province name to the location field and the type of water source column to the color saturation field. Okay, so let's bring the shape map here. Let me expand it a bit. Okay, and then we are told to bring province name to the location. So here's province name to location, and then type of water source to the color saturation field. So type of water source to color saturation. Okay. Now the next thing is to navigate to the format on the visual tab on the visualization page. We'll select map settings and then we'll change map type to custom map. So this is the format type. Okay. On the same visualization pane, format visual, and then we'll go to map settings, and then under map type, we toggle down and select custom map. So after custom map, we'll have to browse to add the map type. Okay, so we go to where we saved our map the one we downloaded from the slide. Mine is in the downloads. I'll just select it and I'll open it. Okay. Now it changes the visualization we have here, right? So the next thing now is we should, on the format tab, select general, then effect and turn background off using the toggle. So on the same visualization, the formats visual pane, we'll select general, and then we'll go to effects, and then we'll toggle off background color, right? So we are done with the visual. Okay. Now the next thing is we then add type of water source column to the filter pane and select tapping home broken to only show data where tapping home broken is shown. Okay. So type of water source, let's bring it to the filter pane. Then we'll select tapping home broken alone. Okay. And then we are done. Right. You should see a map of all the provinces in Maji Ndogo. And it's very hard to know what we are looking at. So let's improve it by placing an image behind the map. Navigate to the Insert tab on the ribbon. And to the right, you can see Select Image. Find MD Map PNG on your computer and select it. Right. So on the home, we go to Insert on the tab. We select Image on the far right here. And then in the where you downloaded the map, you select MD Map. And then we open. Right. So this is what we can see. Okay. The image is displayed over our map, so we need to send it to the background. To do that, we select the image, click on Format on the ribbon, and send backwards, and then send to back. Okay. So we click on the image here. We go to View on the task pane. Hey, sorry. We go to Format on the task pane here. We select Send to backwards, and then send to back. Okay, with this done, we can now adjust the map to, we can now adjust it to fill the size we have in here. Okay, so we'll have to do it manually. Okay. Right. Okay, is it too big or too small? Let me resize this a little bit. Okay. So what I'm trying to do is just to resize it so that the image fits perfectly on the what's the name? The map. Oh, you okay. This will take our time a bit because we need to just adjust it to fit the actual size. Maybe we can get it, as we want, but we can try adjusting it. Oh, I think this should do. Okay. So yeah. So if we click on this, this is for what? Amanzi, this is Akachi, this is Hawassa. Nice, nice. Okay. So as we can see here, this is how it is. Okay. So there were a lot of things we had to do to make this map, but now we can see province by province where the broken infrastructure is. Amanzi is at the top of our priority, then Kilimani. Another cool feature is that you can select the province on the map and we'll filter all the results to only include the province. This is a very intuitive way of adding filter to a page without using the filter pane. Make sure you name this page too, so you can keep the track record of it. Right. So I'll name this broken tab or maybe province. Let me make it broken tab. And then I'll add province to it. Okay. Right. Okay, so let's look at Insight 6 on Q times for a minute. Create another new page, right? Okay. Add a bar chart visual with average Q times on the one axis and the day of week on the other axis. So which one should I even use? Let me use this. So average Q time, right? So time in Q, I'll put it on the y-axis and I'll change it from sum to average. Okay. And then the next one is day of the week. So let me put day of the week on the x-axis, right? So yeah, we can see Saturday, Sunday, Monday, Tuesday, Monday, Friday, Tuesday, Thursday, Wednesday. I think they've been sorted by from the highest to the lowest. Okay, so that is why we are not seeing this way. We can equally make it, sort by the week, so that, but that will change the interpretation of the whole data. This gives a trend like view. The next one is to create a line chart that plots the average times for the hour of the day and add the day of the week as a different colored line. Okay, so line column. Let me bring it here. Okay, so average time in Q. So again, time in Q here, I'll change it to average. And then day of the week. Say average Q time for the hour of the day. So we need to add the hour of the day also to it. Okay, let me put hour of day in the x-axis, right? And then add the days of the week as different colored lines. So in order to do that, I'll just put them into the legend, and then that will break everything down for us for the days we have here, right? So we are done with this part as well. The third one is to create a bar chart that shows the average composition of Qs for each day of the week. Okay, so a bar chart that shows the average composition of Q for each day of the week. So we need to plot the average percentage female, male, and then child on the y-axis and day of week on the x-axis. So I think this is quite straightforward. So percentage female. So we'll go from female, male, and then child. So female, male, and then child, right? We're supposed to find average of all. So I'll change from sum to average, sum to average, right? And then on the y-axis, day of the week on the x-axis. So day of the week will be here on the x-axis. And here we have our data. Okay. Now the last thing is to create a scatter plot with the number of people served versus age of time in Q. Make sure to add filter to this plot and include data where visit count is greater than 1. So let me select the visualization scatter plot. So we have to add number of people served. So number of people served. Number. It didn't say we should aggregate it. It says number. So I'll change it to do not summarize. And then average of time in Q. So what is time in Q? Time in Q should be average here, right? Now the next thing is make sure you add a filter to this, but only include data where visit count is greater than 1. Okay, so I'll pull visit count to the filter section, and I'll use advanced filtering, and I'll say it does not contain, is not, does not start, there's no greater than, so I'll pick is not, and I'll type 1. So it can be everything, but not 1. Okay, right. So this is what we have here. Yes. So Delilah, why visit count greater than 1? Well, I had a look and I notice a data anomaly. If you're curious, before you add a visit time greater than one filter, data on filter, there's a line of values right at the bottom where the queue is 3,000 people long, but still only 30 minutes. We have to look into what happened there. The data is a little enough that, hold on. There's a line of values. Let me remove this, undo this one and see. This is what we are talking about here. So there's a line of values right at the bottom where queue is 300 people long, but still only 30 minutes. So, okay, you can see number of people served, but then queue time is 22 minutes, right? So we have to look into what happened there. The data is little enough that we can't ignore it for now, but it shows you, although we use this data for a while, by visualizing, by visualizing it, we could see a problem now. Okay, so now let me bring my filter here and then go by the normal variable. So it's not 1 by filter. And now this is what we can see here, right? Okay, good. So you can see the same thing here. So your page should look something like this. Okay, so once again, these plots are not formatted well and not laid out well. So we'll have to live with a bit of chaos for now, but let's analyze a bit. So the queue times per day bar chart really brings the point across that Saturdays have very long queues. If you were a citizen, would you get that from this visual? Do we need to change anything to make it simpler or clearer? Would you choose another day to collect water if you saw this? If not, what do you need to see on this visual to get that message? Do you see how we need to think about visualization? It is not just a graph for the sake of a graph. Think through these questions and apply all of the knowledge from the academy to really critically think about it. Anyway, look at the queue time per hour graph now. Can you see that people queue quite similarly during the week, but weekends are different? So, okay, so this is Monday. Let me see, this data particularly. Oh, okay, right. So each line here represents a day. So the one at the top here, I think, is Saturday, and then maybe this is Sunday, I guess, right? So during the week, people queue early in the morning or late in the afternoon, before or after work. On weekends, people queue throughout the day more consistently. So on Sunday, it's quite consistent from the morning through to 6 and even goes up at 7, right? And when we look at Saturday too, from the morning, it's quite stable, goes up a little bit around 10, comes down around 11, remains stable throughout, and then comes up a little bit around 5, down around 6, and shoots back up around 7. Okay, but when we look at the weekdays from Monday through to Friday, it maintains quite a constant, data for all. So in the morning, it's quite constant for all, dips down when it's about 9 a.m., remains stable, and then shoots up again from 4 to 5. And then, that is the trend when we look at the time in queue hour by day of the week. Remember back to your time with Chidi. SQL was very good at assessing and assembling data, but Power BI brings it to life. It's much simpler to see the trends in Power BI, so it's a greater tool for analysis. So you may be asking, Delilah, come on, I can do this in a spreadsheet. You sure could, but select Saturday for a second, right? So when we select this Saturday in here, you will see what happens to the rest of the data. I mean, the rest of the visualization. Okay, so, right. So, pardon me. So once we toggle Saturday, we see what happens to the wait time for Saturday alone. Okay, how the queue starts from 6 a.m., shoots up so somewhere around 10, dips down from 11, grows gradually to 5, dips down again around 6, and shoots straight up around 7 o'clock, right? So it tells the number of people that, have to wait on a particular time on Saturday. When we look at the average percentage, for the male, female, and child, we could see that on Saturday, when you take this is for female and this is for male, yeah, we could see that comparing it to the rest of the days in the week, for Saturday and Sunday, the number of people for, when we take gender, male and female, it's quite almost the same, because female dips down a little bit, but male rises above, comparing it to the rest of the days. Okay, as well as child also goes up a bit. So this really gives some sort of insight, and then maybe there's a reason to that. And then the scatter plot too, when we look, we can always see the upward trend, showing that as the time increases, the number of people served also keeps increasing, So I think there's something we can also take note of. Right. So clearly, with this interactive nature, we can't do this in Excel, as this comment is trying to emphasize. Okay. Once we select it, instantly the RQ time plot shows as the hourly data for Saturday blown up, and we can get even better insight if people have to queue on Saturday 11 a.m. to 6 a.m. There's an error here. This is PM. It has 15% shorter queues. We can't do that in the spreadsheet. Okay. I think maybe the downside we can do a little bit when it's advanced in the spreadsheet. We have to use slicers and whatnot. Okay. Next up, let's look at a clustered bar visual that shows the queue composition for different days. Do you see the gender disparity here? Women queue for water a lot more than men, but we can see over the weekends, men do a lot more. As an analyst, that makes me curious. Why do men queue more on weekdays, on weekends? Maybe men are more likely to work full time, so women are forced to take this responsibility. I read a report recently that shows that women in Africa are the primary water collectors in Africa. They are more prone to injury because they carry these large containers. Women are often attacked when they collect water early in the morning and late at night. Women are the primary child carers, so children often have to go with their mothers and queue for water. This was my mother, and probably yours too. And look at the queues. Women queue with their children in Maji Ndogo too. This is why we need to change things. Lastly, let's look at the scatter plot. Do you remember that the insights from the survey were that we should install an additional tab if the queue is more than 30 minutes? Well, this is the visual Chidi used to make that decision. Without a visual, it wasn't easy to explain, but now you can see our thinking. So you can see the relationship between the queue length and the time it takes is mostly linear. So if you add a tab close to a shared tab 7, 3,000 people, 1,500 of them can use the new one, and 1,500 can use the old one. The queue time drops from 200 minutes to 100 minutes with just one tab. Installing 10 tabs means that 300 people use each tab, and we get a queue time of 40 minutes. While we looked at this, we noticed that the data actually flattens off a bit. We call that plateauing, around 3,000 people said. It puzzled us for a while, but Sana came up with a pretty good explanation. If queues are too long, people give up. The queue times don't increase much past 3,000 because people see long queues and go look water in other places. So remember that reports about water access for women I mentioned. Sana had a look at some old crime records in Maji Ndogo and managed to link thousands of crimes in the past 10 years to specific water source locations. These crimes happened at the locations in our current data set, as our people were traveling to and from that location. Each crime has a unique crime ID, the type of crime that was committed, the gender of the victim, and the location ID. To make it simpler this week, I added the day of the week and the hour of the day to that crime record. Next time, we'll have a dive into this data a bit deeper, but you should explore it. Visualize the number of crimes committed by type, province, and type, splits by victim gender. See if you can find a relationship between queues and crime happenings. For example, are there days when the queues are long and there are a lot of crimes happening as well? Maybe it's something we can play along with. Good luck. I look forward to seeing you next time. Remember to collaborate with your teams. Together, we are more. So this brings us to the end of the project for this week. So for last week, maybe on our own we can try and work out this one using the related crime scene, and then see if we can draw any visualization and insights from there. So I'll end the video now, and then in case anyone needs any clarification, as always, you can always reach out, and I'll be glad to assist. Thank you.